everyone. Welcome to Tricks for Maths. This is Sharda Hegde. We are talking about real numbers of grade 10. We have completed irrationality of numbers. We proved that, and rational numbers and their decimal expansion in our previous videos. If you have not gone through that, please go through those videos. And in this video, we are learning Theorem 1.1 in your textbook, that is Euclid's Division Lemma. Okay, and also we are learning Euclid's division algorithm to solve many problems. So what do you mean by Euclid's division algorithm as well as Euclid division lemma? Here you are observing two statements. Okay, a lemma is a proven statement used for proving another statement. Once again I'll read. A lemma is a proven statement used for proving another statement. Let me give an example for this. Yes, we already learned that a plus b the whole square equals to, yes, a square plus 2ab plus b square. Okay, this is nothing but lemma. That means already proven statement. Okay, so we use this lemma in order to prove or in order to find out the values in other examples. Okay, let me take one example. 5 plus 6 the whole square equal to 121. Prove this. So what you will do? Yes, 5 plus 6 the whole square. For this term, you will apply the rule a plus b the whole square, right? Or you can directly do 6 plus 5 is 11, 11 square. Or in order to apply the formula, how will you do this? Yes, 5 plus 6 the whole square, 5 square plus 2 multiplied by 5 multiplied by 6 plus 6 square. So it is nothing but 25 plus it is 60 plus it is 36. So this gives you again, sorry, it is plus. Okay, this gives you 121. We proved 5 plus 6 the whole square equals to 121. That means this statement which is already proven is called lemma, as well as the whole thing what you have solved, an example, is called algorithm. Okay, so an algorithm is a series of well-defined steps. You are observing it is a series of well-defined steps which gives a procedure for solving a type of problem. Here you solved one problem and you used a lemma and you followed a series of well-defined steps. In your example, the numbers may be changed, but you will follow the same steps, right? You will apply the formula, you will solve, you will simplify, and you will get the answer. So this is nothing but an algorithm. I hope you now can differentiate what is lemma and what is algorithm. In real numbers, they dealt with Euclid's division lemma and algorithm. So what is division lemma? We will discuss Euclid division lemma by taking few general examples. Here I am taking 5 divided by 2. Okay, that means it is dividend. Okay, it is dividend, and this is divisor. Here it is divisor, it is dividend. So how will you do 5 by 2? It's very simple. 2 2s are 4, 5 minus 4 is 1. So here it is quotient, right? Here it is quotient and this is remainder. Now, in order to get 5, what you did here? Yes, by just observing the division problem, I can say that I multiplied 2 by 2 and added this remainder 1, then I can get 5, right? So 2 multiplied by 2 plus 1 gives me 5. 2 2s are 4 plus 1 is 5. That means what I did here, in order to obtain dividend 5, okay, I just multiplied the divisor and a quotient, okay, divisor and quotient, and then I added the remainder to the product. We will take one more example here. 39 by 7. So 7 5s is 35. 39 minus 35 is 4. Yes, here it is divisor, here it is dividend, okay, dividend, and this is here quotient, and it is remainder here. Now how can I obtain 39? Yes, 7 multiplied by 5, that means divisor multiplied by quotient plus remainder. 7 5s are 35 plus 4 is 39. Okay, in both the cases we multiplied quotient and divisor and we added remainder. Okay, so in general, if I take any number A, okay, and if I divide that number by B, I will get quotient Q and remainder R. Remainder may be 0. Okay, in these both the cases, just we got remainder 1 and 4. But if the given number is exactly divisible by the divisor, we will get quotient as 0. Yes, we know that. So how can I write this? A is a dividend. A can be obtained by doing BQ and adding R. Okay. So BQ plus R I can write. Yes, we discussed R may be 0, but R can't be greater than B. Yes, B is the divisor here. R will not greater than B. Yes, divisor, if it is greater than B, again we can continue the division process, right? So in general, how we will write? A is equal to BQ plus R. This A is equal to BQ plus R, where R lies between 0 and B, or in other words, R is greater than or equals to 0 and less than B. This is nothing but Euclid's division lemma. Okay, so what does it states? Given positive integers A and B, okay, divisor and dividend, there exist unique integers Q and R, okay, Q and R satisfying A is equal to BQ plus R, where R is greater than or equals to 0 but less than B. So we use this Euclid's division lemma in order to find out HCF of any given two numbers. Okay, that is nothing but Euclid's division algorithm. Okay, algorithm means it's a well-defined series of steps in order to solve the problem. So it is a technique to compute HCF, okay, highest common factor of two given positive integers. So we will use Euclid's division lemma in order to find out HCF of any two given large numbers. So directly we will move to your textbook problems. That means exercise what they have given in your textbook related to Euclid's division algorithm. One by one we will solve those. So here is exercise 1.1, which is based on Euclid's division algorithm as well as lemma. So first question, use Euclid's division algorithm to find the HCF of three sub-questions are there. The first question now we are going to solve. Use Euclid's division algorithm to find HCF of 135 and 225. So here we are comparing both the numbers. Which one is bigger? 225 is bigger one. So we are going to divide this 225 by 135. Yes, here it is dividend and it is a divisor. So we will solve step by step. I am dividing 225 by 135. Okay, so 135 ones are 135, 5 minus 5 0, and 12 minus 3 is 9, 1 minus 1 is 0. Okay, so how can I write this? 225 equals to 135 multiplied by 1, divisor and the quotient I am multiplying, plus what is the remainder here? Plus 90. Okay, so this is the first step. 225 equals to 135 multiplied by 1 plus 90. So this is the first step. I'll go for second step. Now we obtain 135 and 90. Okay, so 135 by 90. 9 ones are, I can't go for 9 twos are, it will become 180 something, right? So 190 only I can write. How much will remain? 45 will remain. Okay, so this is the remainder, this is the divisor. How can I write 135 then? 135 equals to 90 multiplied by 1 plus 45. Now, what will be our next step? Yes, I can divide 90 by 45. These two I am taking. This 45 and 90 I am taking. 45 2s are 90. So, our remainder is 0 here. Yes. Now, we can't go further. I can write this as 90 equals to 45 multiplied by 2 plus 0. I got 0 here. So, here the divisor is 45. You are observing here. This is nothing but HCF. Okay. So, what will be the divisor when you are at stage the remainder is 0? That will be your HCF. So, HCF for 135 and 225 is 45. The answer is 45. Okay, HCF is 45. It's very easy. Please use Euclid's lemma in order to find the HCF. Let us go for the second example. Use Euclid's division algorithm to find HCF of 196 and 38,220. Here 38,220 is bigger one, so we are dividing this by 196. Okay, first step, we need to go for 382 because it's a 3-digit number. First we will take a 3-digit number group, 382. 196 ones are 196 only. Okay, so if we go for subtraction, we will get 186. Then again we will take this 2, okay, in front of 6. So it becomes 1862. We now divide this by 196. 9s are 1764, 1764. If we go for subtraction here, we will get 98. And this 0 will come in this position. Okay, 0. So again 5s are 98 itself. So we got 0. With only one division method we will follow. We got 0. So how can I write 38,220 equals to 196 multiplied by 195 plus 0. Okay. Yes, here what is the divisor? 196 is the divisor, right? So this divisor is only nothing but HCF for these two number. Okay, 196 is the HCF of the given example. Here is our third example. Use Euclid's division algorithm to find HCF of 867 and 255. Here 867 is a bigger number, so we are dividing this by 255. So our first process is 867 divided by 255. Okay, so it goes by 3. 3 5s is 15. Okay, 1 is carry over, and again 15 plus 1 is 16. Again 1 is carry over, and 3 2s is 6 plus 7. Okay, now 7 minus 5 is 2, 6 minus 6 is 0, and 8 minus 7 is 1. So 102 we got as a reminder. So 867 can be written as 255 multiplied by 3 plus 102. Okay, so remainder is not 0. We can go for again division by taking 255 and 102. Okay, so now 255 divided by 102. We can go for 2. 2 2s are 4, 2 0 0, and 2 1s are 2. Okay, 1 5 and 0. 51 is a remainder. So 255 can be written as 102 multiplied by 2 plus 51. Again I can go for one more division process. It is 102 divided by this 151 I am taking. 51 2s are 2 1s are 2, 2 5s are 10. It is exactly dividing, right? So that means I got remainder 0, right? Here 0 is the remainder. So I can write 102 equals to 51 multiplied by 2 plus 0. So we got 0 as reminder. In this stage, divisor is 51. Divisor is 51. So this is the HCF. Okay. So HCF of these two number is 51. Okay. It's very simple. Let us go for the second problem. Okay. Second question in exercise 1.1. Show that any positive odd integer, okay, positive odd integer of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, what they are asking, we need to prove that any positive odd integer will always be represented in the form either 6q plus 1 or 6q plus 3 or 6q plus 5. Yes, we are observing, we know that the lemma, okay, it is of the form bq plus r. Yes, are you observing? It is b, it is q, it is r. In this case also, bq plus r, bq plus r. Okay. So, for some integer, that integer can be a or b or c something. Okay. So, we can write, let a be any positive integer. I am not talking about odd here in the initial stage. I am taking a as any positive integer and b is equal to 6. That means divisor is 6. Why it is 6? Yes, we know it is 1, 3 or 5 where q is some integer, and it is clearly you are observing in all the three cases it is b. It represents b. Okay, 6 is b only. So b is equal to 6. Then by Euclid's division algorithm, how can we write this? A is equal to bq plus r, that is nothing but a is equal to 6q plus r. Just I substituted this value in the place of b. That means a is equal to 6q plus r. For some integer q is greater than or equal to 0 and r is 0, 1, 2, 3, 4, 5. Why it is like that? Yes, we know greater than or equal to 0 and less than 6. Why it is 6? Divisor is 6. So what may be the values? 0, 1, 2, 3, 4, 5. Okay, less than 6. It becomes 0 to 5. Now, I can substitute these values in this equation, r, values of r. Then I can write a as 6q. Why 6q? If I put 0, 6q plus 0 becomes 6q only. If I put 1 in the remainder, it becomes 6q plus 1, 6q plus 2. Just I am replacing the value of r. Okay, 6q plus 2 plus 3 plus 4 or plus 5. Now, in the question we are talking about only odd numbers. We need to prove that about 6q plus 1, this, 6q plus 3, this one, and 6q plus 5. And you are observing 6q, 6q plus 2, 6q plus 4 are even numbers. Do you agree for that? Yes, because 6 is even. It is any integer. If you multiply by that number, it gives you even only. And you are adding even number itself. Okay. That means 6q, 6q plus 2, 6q plus 4 is even. But we are not talking about even numbers. Let us check. 6q plus 1, 6q plus 3 and 6q plus 5 are even or odd. Okay. So we will consider those three only. Now first of all, we are considering 6q plus 1. Okay. So 6q plus 1 can be written as 2 into 3q plus 1. Okay. That means 6q can be written as 2 into 3q. There is no change in the value. Okay. 2 3q plus 1. So that 3q, okay, that 3q is replaced by some positive integer k1. Okay, some positive integer k1. 3q is nothing but k1. Okay, some positive integer. Let us go for 6q plus 3. How you can write? If you take common, 2, it becomes 3 can be written as 2 plus 1. Okay, if you take 2 common, it becomes 3q plus 1. Okay, yes, here it is 2 common, then 3q will be remain, and if you take 2 common, here it will become 1. So 3q plus 1, that 3q plus 1 is also equals to k2, which is a positive integer. Okay, that means you are representing in the form 2k plus 1, 2k plus 1. Let us go for 6q plus 5. Here 5 can be written as 4 plus 1. Again you can take out common 2. If you take out 2 as common, you will get 2 into 3q plus 2 plus 1. So here 3q plus 2 is k3 for some integer, some positive integer. Okay. Again you represented 6q plus 5 as 2 some positive integer plus 1. Okay, in all the cases you represented as in the form 2k plus 1. See, you are observing these 3 cases. Okay, you represented 6q plus 1, 6q plus 3 and 6q plus 5 are of the form 2k plus 1, where k is an integer. Okay, hence it is not divisible by 2. Do you agree? Yes, because k is some integer, you are multiplying by 2, okay, you will get even number. But if you add 1 to that even number, what you will get? An odd number. So it is not exactly divisible by 2, hence it is an odd number. Okay, so the given expression is an odd number, hence we can conclude that any number a, positive odd integer, can be expressed in the form of only 6q plus 1 or 6q plus 3 or 6q plus 5. So in this example, what they did, how they solved? Just take Euclid's division algorithm. Okay, substitute the values of r remainder just by observing the divisor in the given question. What will be the divisor? In this question it is 6. So please put the values 0 to 5. Okay, so you will get different expression. If you guess if it is even or odd, you will easily prove the given statement. They have asked for odd here. Yes, we proved that any odd integer can be expressed in the form of only 6q plus 1, 6q plus 3 as well as 6q plus 5. Let us go for the third example in your textbook. That is, an army contingent of 616 members is to march behind an army band of 32 members in parade. Okay, in parade there will be 32 members in an army band and 616 members an army of contingent. Okay, the two groups are to march in the same number of columns. Columns should be same. What is the maximum number of columns in which they can march? Here they are asking about maximum number of, that means highest, right? It is nothing but highest common factor. That means HCF of 616 and 32 you need to find out. In this first main we solved 3 questions. Please go through the same. Okay, you will follow the same steps. You can find out the HCF of 616 and 32 very easily. Let us move to fourth problem. Our fourth problem is use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, here also they are asking for square of any integer. Okay, so we need to go for squaring and we need to prove it is of the form 3m or 3m plus 1. One hint they have given, let x be any positive integer, then it is of the form 3q, 3q plus 1 or 3q plus 2. Now square each of these and show that they can be written in the form of 3m or 3m plus 1. Okay, so we know if it is written in the form 3q or 3q plus 1 or 3q plus 2, we know how to use Euclid's division algorithm to solve this, right? So let a be any positive integer and b is equal to 3. Why it is 3? Yes, clearly it is bq plus r, so b is 3. Okay, b is 3. If it is 3, what will be the reminders? Yes, it is 0, 1 or 2 because it is less than 3, right? Less than 3 is nothing but 0, 1, 2. We are going to substitute the values, right? So therefore a is equal to 3q, because if we substitute 0 in the reminder place, we can directly write 3q. 3q plus r is nothing but, 3q plus 0 is nothing but 3q, 3q plus 1, 3q plus 2. Okay, substituting 1 and 2 respectively. Now the second step is they are asking for squaring, right? So squaring on both the sides, we will get a square. Okay, a square is equal to 3q square, or 3q plus 1 the whole square, or 3q plus 2 the whole square. We know square of a plus b, right? The formula a square plus 2ab plus b square. We use the same formula in order to solve this problem. We will get 3q the whole square is nothing but 9q square. But if I take common 3 from that 9q square, I can write 3 common 3q square. Okay, there will be no change in the value. Again 3q plus 1 the whole square is 3q square plus 6q plus 1 by solving using equation a plus b the whole square. Similarly 3q plus 2 the whole square, if I use that formula, I will get 9q square plus 12q plus 4. Now this can be rewritten, or by taking common 3, I can write 3 into 3q square is written here. For this I can take 3 common. If I take 3 out, then 3q square will be remain, and 2q for this 6q plus 1 is extra. Okay, this plus 1. That means I represented 3 into something plus 1. Okay, now 4 can be written as 3 plus 1 here. So if I take common 3 here, it will become 3q square, it will become 4q, and 3 becomes 1 because I already taken common here, and this last plus 1, this one goes here. Okay, this is also expressed in the form of 3 into something plus 1. So you are observing here, 3k square, 3q square is k1. Okay, for some positive integer k1, and this is also can be expressed as 3 into k2 plus 1 for some integer k2, 3k3 plus 1, 3 into k3 plus 1 for some integer k1, k2 and k3. On the whole, for all the three different equations, we can write k1, k2, k3, some positive integer we can express like that. Now we can directly say that the square of any positive integer is either of the form 3m or 3m plus 1, 3m or 3m plus 1. Okay, here they are considering m as k1, k2, k3 for some positive integer. So you can only express in the form 3m or 3m plus 1. It is very easy. Just go through Euclid's division algorithm, use lemma that a is equal to bq plus r, substitute the values of remainder. Okay, just by observing the question you will get divisor b, and please put the values, you will get the answer. So need not to solve the fifth question, because in this question they asked for cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. That means in this example you will substitute the values and you will take the cube of that number. Okay, in the previous example we used to square. In this example you will go for a plus b the whole cube formula. You will solve. It is very easy. Please try to solve yourself. So we completed exercise 1.1 with the concept explanation. I hope you understood better the concept. Please solve by yourself. I hope you liked the video also. Please share with your friends. If you are new to my channel, please subscribe my channel and you will get the videos on all the chapters of grade 10 in the coming days. Please support. I'll meet you in the next video with more information regarding real numbers itself. Till then, take care. Bye-bye.